So in this problem, we need to determine the value of the given trigonometric expression for two cases. One when the n value is odd and the other case when n is even. Now, we can clearly observe here that if we consider the first term, then in the numerator we have the sum of two cosine functions. In the denominator, we have the difference of two sine functions. Then in the second term, in the numerator part, we have the sum of two sine, and in the denominator, difference of cosine. So here we will be using the transformation formula. So let me state the formula that we will be using here. So we can see, so if we have the sum of sines or difference of sine, it transforms as a product of sine and cosine. And if we have the sum of cosine function, it transforms into product of cosines. Whereas for the difference of cosine, it transforms into product of sine. We will be using these four formulas. So let us rewrite the given expression. So we have cosine of a plus cosine of b in the numerator. So this will become 2 times cosine of angle a plus b over 2 multiplied to cosine of angle a minus b over 2 whole divided by, now we have sine a minus sine b, so we're going to use the difference of sine function. This is going to give us 2 times cosine of angle a plus b over 2 multiplied to sine of angle a minus b over 2 whole raised to the power of n. Next, in the next term we have sine a plus sine b, so that's the sum of two sine function. So we have 2 times sine of angle a plus b divided by 2 multiplied to cosine of a minus b over 2 whole divided by we have the difference of cosine function. So we have negative 2 times sine of angle a plus b over 2 multiplied to sine of a minus b over 2 whole raised to the power of n. Now here we can factor out 2 and cosine of a plus b over 2 from the numerator and the denominator for the first term, and the second term we can factor out 2 sine a plus b over 2 from both the numerator and the denominator. So that's going to leave us with, so we have cosine of a minus b over 2 divided by sine of a minus b over 2. So this ratio is nothing but the cotangent function, because we have the same angle for both cosine and sine. Therefore, cotangent of a minus b over 2 whole raised to the power of n added to, and here we have the same thing, but we have cosine of a minus b over 2 and sine of a minus b over 2. We also have to be careful, there's a negative sign here, so we have negative times cotangent of a minus b over 2 whole raised to the power of n. Fine. So we now have cotangent raised to the power of n of a minus b over 2. Now since we have the negative sign here, we can also rewrite it as negative 1 raised to the power of n multiplied to cotangent raised to the power of n of a minus b over 2. So here we have two terms, and put the two terms, the factor cotangent of a minus b over 2 whole raised to the power of n is a common factor, so we can take it as common. So we have cotangent of a minus b over 2 whole raised to the power of n, so this will be multiplied to 1 plus negative 1 raised to the power of n. Fine. So this is the value of the given expression after we have applied the transformation formula. Now we go to the case, the first case when n is an odd number. So let's do that. So part 1, our n is odd. If our n is an odd number, so let's say n can be represented by 2 times k plus 1, where k is some other integer. Then we have 1 plus negative 1 raised to the power of 2k plus 1. All we are doing is replacing the value of n with 2k plus 1. So this will be equals to 1 plus, so we have negative 1 raised to the power of 2k multiplied to negative 1 raised to the power of 1. Now this is always going to be positive because we have negative 1 squared. So we have 1 plus, but this is negative 1, so this is going to give us a value 0. So regardless of what value of k we choose, if n is an odd number, then this entire expression is going to be 0, and we'll see final value is going to be 0. Fine. And if it is an even number, so if n is an even number, then we can represent n as 2 times p. Then in that case, 1 plus negative 1 raised to the power of 2p. So this will be simply 1 plus 1, which will be equals to 2. And our final value will be, 2 times cotangent of a minus b over 2 whole raised to the power of n. So this is going to be the final value.